Hello, my name is Bridget White. My week 8 presentation is taken from lesson 20C and it is on spine leaf typology or architecture. What is spine leaf architecture? A network typology that prioritizes scalability, low latency, and redundancy. It's a full mesh, two-layer network typology used in data centers that typically experience more east to west network traffic. This typology is commonly used in data centers made up of a top tier of aggregation switches, which form the backbone for the leaf tier of top of rack switches. Top of rack, or TOR, is a high performance switch model designed to implement the leaf tier in a spine and leaf typology. In this next slide, I'm going to explain the different layers of spine and leaf layer. I'll start with the spine layer. It is made up of a backbone of top tier switches that are not directly connected to one another. Leaf switches connect to spine switches and mesh into the spine, forming the access layer that delivers network connection points of servers. The leaf layer is made up of access switches, with each access switch connected to every spine switch, creating that full mesh typology. The access switches also never directly connect to each other. Servers and storage connect to leaf switches and consist of access switches that aggregate traffic from the servers. And then the picture on the right is just an example of what a spine and leaf typology would look like. In this next slide, I'm just going to go over some of the differences between spine and leaf typology or architecture versus a traditional three-tier architecture. So that traditional three-tier architecture typically handles north to south network traffic. It's made up of 3 layers, and that includes the core layer, the aggregation and distribution layer, and then the access layer. That core layer interconnects the data center aggregation modules while connecting to the core of a network. The access switches connect to servers and storage devices, while the aggregation layer brings together access layer traffic and provides a redundant connection to the access layer. The three-tier architecture uses some protocol called the STP, or the spanning tree protocol, and that protocol basically prevents loops from being formed when switches and or bridges are interconnected via multiple paths. One of the main differences between the spine leaf and the three-tier typology or architectures is that the spine leaf does not need to use the STP protocol, and that's because the spine leaf architecture collapses one of those tiers, as we saw in the previous diagram on the last slide. Some of the other differences in the spine leaf typology include one, like I mentioned before, the removal of the STP protocol, increased use of fixed port switches over modular modules for the network backbone, more cabling you have to purchase and manage given the higher interconnection count, and then a scale out versus scale up infrastructure. And then lastly, I have another diagram just showing the differences between spine and leaf and the three-tier architecture. And then I'll go over some of the benefits of using a spine leaf architecture in your data center. That includes each server is only ever a single hop from the backbone, making network latency more predictable. There are multiple redundant paths between a leaf switch and the backbone, allowing for load balancing and failover. As there are no direct connections between the spine switches and the backbone or between leaf switches, the network is loop-free and does not need to run spanning tree. Instead, each leaf switch runs a protocol called equal cost multipath, or ECMP, to distribute traffic between the links to the spine switches. Also, servers are connected to multiple leaf switches for a multipath redundancy, using a first hop gateway protocol to determine the active path. And that's going to conclude my presentation for week 8 on the spine leaf architecture or typology used in many data centers.